In this video, we're going to talk about how to find ratios and rates. A ratio is a comparison of two quantities using division. You can write ratios in three ways. You can write it with that colon, you can put the word 2 in the middle, or you can write it as a fraction. No matter which way we write it as, we read them all as A to B. We should also keep in mind that we should write ratios in simplest form. We should also not change improper fractions to mixed numbers, because if you change it to mixed numbers, you don't see that comparison anymore. So example 1, we're going to write ratios in simplest form. We're going to look for a number that divides evenly into both of them. So for 25 and 10, both of them are divisible by 5. So I'm going to divide 5 out. So that becomes 5, and 10 divided by 5 is 2. So our simplified ratio is 5 to 2. For 6 and 18, 6 goes into both of them, so I'm going to divide 6 out. That gives us 1 to 3. What you could also do, if you prefer working in fraction form, you can write your original ratios as fractions first. So this would be 25 over 10, this would be 6 over 18, and we know how to simplify fractions. Okay, the steps would be the same, it just looks a little bit more familiar. So you're allowed to write it as fractions first if that's easier for you. Example 2, writing ratios from a word problem. You have to really be careful of what the ratio is asking you to find, and the order that it's given to you in is also important. So an archer shot 60 arrows at a target with 44 arrows hitting the scoring area. First, we're going to rate the ratio of the number of hits to the total number of shots. I like writing things out in words first, so I'm going to put hits over total. And it tells us the number of hits. It says 44 hit, and it also tells us that there were 60 total shots. And now while it didn't say to write it in simplest form, we should get in the habit of always writing our ratios in simplest form, even if it doesn't tell us to. So I'm looking here, I can see 2 goes into both of them, so I'll divide 2 out. That gives me 22 over 30. But they're both even still, so it looks like I can do another set of 2, and I get 11 over 15. For B, it wants us to write the ratio of the number of hits to the number of misses. So to set this one up, it's going to be hits over misses. And we already knew that the hits was 44, but unfortunately it doesn't tell us how many misses were in the question. However, we can definitely figure this out if we know that there were 60 total shots and 44 of them hit. We just have to do 60 minus 44, which is 16, and that's how we can figure out how many misses there were. So our original ratio is 44 over 16. I know 4 goes into both of them, so I'm going to divide 4 out, and I get 11 to 4. For number 2, it says in a jar there are 6 blue marbles, 3 red marbles, 7 green marbles, and 2 yellow marbles. Write the ratio of red or green marbles to the total number of marbles. This one is a little bit different. Okay, in this one we have it asking us for red or green. So if that ever happens, okay, you're actually going to combine the two of them together. So there are 3 red marbles and 7 green marbles. So if I'm looking for red or green, that means that there would be 10 options. Okay, so I'm going to set this up as red or green over the total. We said that the red and the green, that was 10. The total, well, we already did the red and green, so we have to add in the blue and the yellow. So really 6, 3, 7, and 2 add up to 18. And of course we need to simplify. They're even, so let's divide by 2. We get 5 over 9. And for the last one in this example, it says the ratio of Mets fans to Yankee fans at a game is 4 to 5. Write a ratio of the number of Mets fans to the total at the game. Okay, so we're definitely going to have Mets over total, but they don't actually give us the number of people that were at this game. So we have to use that ratio that they're giving to us. So in this ratio, it's 4 parts Mets and 5 parts Yankee fans. Okay, so if we look here, all together there are 9 parts in this ratio. So I can say the Mets part was 4 and the total parts is 9. So even though they didn't give us actual numbers, we can still use the parts of the ratio to help us out. So 4 over 9 is our answer for that one. Example 3, we're going to determine if ratios are equivalent, okay, if ratios are equal. So it gives us a ratio, we need to figure out which of these options it is equivalent to. Okay, so with ratios, we're always looking to see, can we multiply or divide our numbers, okay, in the same way to get that answer? So I'm looking at this, if I have 2 to 5, to get to 4, I would multiply by 2. If I try to do that to the other number, 5 times 2 is also 10, so that would be an equivalent ratio. For the next one, I'm going to say 2 times 3 gives me 6. If I tried to do 5 times 3, though, that would be 15, not 20, so that one is not equivalent. Okay, pretty much if the rule doesn't work for both of them, okay, then it is not equivalent. The next one, okay, I can't really go from 2 to 5, but I can certainly go from 5 to 25, so I'm going to start on the right-hand side for this one. 5 times 5 would be 25. 2 times 5 would be 10, so that one is not correct. And for the last one, I'd say 2 times 8 would give me 16, so 5 times 8 would give me 40, which is good. So the first and last ones are equivalent to that original ratio. For number 2, okay, I'm looking here, I'm trying to do 15 to 20, see how that's related to 6 to 8. Okay, but 15 and 6, I can't really go from one to the other with multiplying or dividing. 20 over to 8, same thing. So I'm going to go back to that original ratio, and this is a good strategy. Okay, we can actually simplify that original ratio. So 15 and 20 are both divisible by 5. So I'm going to simplify this, and really we want to look at that simplified ratio of 3 to 4. And this is what I'm going to use to see if these other ratios are equivalent. So 3 to 4, I would do 3 times 2 to get 6. Let's see if it works. 4 times 2 would be 8. That is good. I would do 3 times 6 to get 18. 4 times 6 is not 21, so that does not work. For the next one, I would do 3 times 3 to get 9. 4 times 3 would be 12, not 10. And for the last one, 3 times 9 gives me 27. 4 times 9 gives me 36. So once again, the first and last ratios were equal. Example 4, ordering ratios from least to greatest. Okay, here we definitely need them all in the same form. Okay, so I have a bunch of different forms of ratios. I'm going to say fractions is the easiest one to work with, the most common one. So I'm just going to start by rewriting all of my ratios so that they look like fractions. So now that they all look like fractions, I could try to compare them, but unfortunately, trying to compare fractions, you have to find common denominators and then change your numerators. It's a lot of work. So for this part only, okay, usually we don't necessarily do this with ratios, but let's just change them to decimals. Decimals are a lot easier to order. So to do that, we're going to take the numerator and divide it by each denominator. So 4 divided by 2, 11 divided by 2, 22 divided by 3, 30 divided by 4, and 36 divided by 5. And you would totally be using a calculator at this point. So for our numbers, we would get 2, we would get 5.5 for the next one. This one ends up being a crazy decimal, so we can just leave it as 7.3. Next one is 7.5 and 7.2. The decimals themselves don't necessarily need to be exact, especially this one that's repeating, that 22 over 3. Okay, but we can just round as long as none of them have that same number that's in that tens place. And now that we have them in decimal form, we can write them in order. So this would be first, because it's the smallest. We're going from least to greatest. The 5.5 would be next. Now we have 7.3, 7.5, and 7.2. So 7.2 would be the smallest, then 7.3, and then 7.5. And you'll notice that last step says rewrite them in the original forms. Okay, we don't want to leave them in this decimal form. So the first one was this 2, but its original ratio was 4 over 2. The next one is 5.5. Its original ratio was 11 to 2. Next came this 7.2. That was 36 to 5. We then have this 22 to 3. And lastly, the 30 over 4. Okay. Last little bit. A couple more vocab words. Rate is a ratio of two quantities with different units. And a unit rate is a rate that has a denominator of 1. Okay, so we're going to start with some rates. You'll notice like here we have dollars and pizza, miles and hours, dollars and days. Okay, so we're still comparing things, but they have different units on the top and the bottom. For unit rate, our goal is to make the denominator 1. So it's kind of like we're writing an equivalent ratio with that denominator of 1. So if I want this to be 1, okay, I'm looking at that 4 right now. If I want that to be 1, I would have to take that 4 and divide it by 4, which would give me 1 pizza. But the rule is whatever you do to the bottom, you must also do to the top. And $44 divided by 4 means it's $11. So if you paid $44 for 4 pizzas, you would end up paying $11 for 1 pizza. For the next one, to make the denominator become 1, I have to take that 5 and divide it by 5. So that would be 1 hour on the bottom. I have to do the same thing to the top. And 300 divided by 5 is 60 miles. Notice how I'm still including the units in my answer. Okay, if I just have numbers, I'm going to mark things wrong. Okay, so I have to have units in there. The last one, we're going to divide by 3, which gives us 1 day. And do the same thing to the top. Definitely using a calculator. That's going to give me 75 cents. So unit rates, make that denominator 1. Whatever you do to the bottom, do to the top. Last one. Okay, when you go to the grocery store, okay, you can get each product in a bunch of different sizes. Okay, sometimes there's small ones and the giant family pack and then the regular size. Okay, you have to figure out, if you're a good consumer, which is the best buy, what you're getting the most amount for with your money. Okay, so for these, you have to remember this because I will not tell you the formula, not necessarily the formula, but how you're going to set this up. You're going to take the cost and put it over the size. Okay, that is important. Cost over size. So let's say we have a Cheerios. We'll deal with Cheerios. You can get an 8-ounce box that costs 96 cents. We can get a 16-ounce box that costs $1.60, or 24-ounce box for $2.64. I want to know which of these will I get the most amount of Cheerios for my money. So I'm going to set up 3 separate ratios, okay, using this price over size. So for the first one, it's 96 cents over 8 ounces. The next one is $1.60 for 16 ounces. And the last one is $2.64 for 24 ounces. And now I want to know how much I'm paying for each ounce. So really, this is just the same thing we did with our unit rates. So here I'm going to divide this by 8 to get that 1 ounce. So I must divide that by 8, and that ends up being 12 cents for each ounce. For the next one, I would divide it by 16 to get 1 ounce. So if I divide the top by 16, that ends up being 10 cents per ounce. And the last one I'm going to divide by 24. Divide by 24 then. If I use my calculator, that's 11 cents per 1 ounce. Okay, so the one that's the cheapest per ounce is this, whoops, sorry. Highlighter did not work, there we go. This one, that's the cheapest per ounce. So this package is the best buy.